Okay, welcome again. This is JBTeguihanon, Engineering and Chemistry tutorial. For those of you who have not yet subscribed to my channel, please subscribe. JBTeguihanon, Engineering and Chemistry tutorial. Let's continue our study in refrigeration, introduction to heat, and then we just discuss we just define BTU, right? British Thermal Unit. And right now we are going to study the three mode of heat transfer. Okay. So I'll be using this to illustrate, but I'll use my my PDF, the other presentation to give you the formula. Okay, conduction. Okay, we have here conduction. Okay, conduction is heat transfer by conduction can be explained as an energy actually traveling from one molecule to the other. As a molecule moves faster, it causes nearby molecules to do the same. Okay? For example, if one end of a copper rod is placed in a flame in a short time, the other end will have two to handle. Okay? And that is conduction. Uh, like this one. So figure 1.8 here. Okay, this illustrates the conduction. So you have a flame, you have a copper rod, okay, you heated it, this portion, and then molecules moves, the molecules of a copper, and then you your hands had feel the heat sooner or later. And that is heat transfer by conduction. Okay? Now let's switch to other presentation to show the um, formula. Okay, for the uh, conduction, we have this formula here. Okay, uh, conduction is heat transfer exists according to conduction. Heat transfer exists in a material due to the presence of temperature difference. Okay, and this is temperature difference within the material. So in our illustration, that is copper rod. Okay, in the copper rod, there had been there had been a transfer from flame because flame has a high temperature. So high temperature here, temperature is high and temperature is low. So because of the difference of these two, there is a transfer of heat by conduction. Okay, suppose this is 75, or sorry, suppose this is 100 degrees Celsius. And suppose here it's like at room temperature, shall we say 27? degrees Celsius. Right. So 27 minus, sorry, 100 minus 27, that's a lot, right? There is a difference of how much? Uh, how much? 100 minus 27, right? It's 10, this is 3, and this becomes 9. Okay, 9 minus 2 is 73, right? So this 73 Celsius is what he calls temperature difference, right? Difference. So that is the driving force according to thermodynamics. The driving force of conduction or heat transfer by conduction. Okay? So, uh, according to this, it can exist in all substance, but in most often associated with a solid. Okay, it is expressed mathematically by the Fourier law of heat transfer, which is for one-dimensional plane, will take the form Q is equal to constant K, that is the thermal conductivity, times area A, right, times the driving force, which is temperature difference. A is the wall area. Then you have the what do you have here? You have the L, the bottom. You have here L. Okay. So your formula gonna be like this: Q, or heat transfer due to conduction, is equal to K times A times delta T over L. Okay. Now, if R is given, this will change. R is given, and R is equal to what? L over K. L over K, you have here L, you have here K over L, right? So if the R is given, your Q, or heat transfer due to conduction, will be like this, is equal to area times delta T over R. You are now considering R, R of the material. Okay, math. This will be your formula if R is given. Okay, so that's all for tonight. For now, for those of you who have not yet subscribed, please subscribe to my channel, JBTeguihanon Engineering and Chemistry Tutorial. Bye for now. God bless.